Alright, in this section we're going to talk about pizzas. Well, actually not pizzas, but we're going to talk about circles. And circles always remind me of pizzas for some reason. If you were going to eat a whole pizza, you would need to know the area of that pizza. Well, you wouldn't need to know the area of the pizza, but it would be kind of nice to know the area of the pizza. If you were a little less greedy, you may want to share that pizza with other people, and you may slice it up and you may give a sector to your friends. Since you and that would obviously make you a very popular person. So let me oh, I did not mean that. So let's try again. And for simplicity, we will say you're going to only divide your pizza into 4 quarters or 4 sectors. So what is a sector? Well, I love to use the highlighter, so I shall highlight that for you. This sector, and we will pretend that Mrs. X, I don't want to identify myself. Mrs. X cut this pizza so that these are all right angles. So it would stand to reason that that piece of the pizza would be 1/4 of the whole pizza, or 1/4 of the whole circle. So its area would be 1/4. Did I say 1/4? I think I did. Now I also want you to contemplate on this. The area of the circle, this is another shortcut for writing circle, is proportional to 360 degrees, and the area of the sector in the above case, in the pizza case, is proportional to 90 degrees. And we already sort of determined using common sense that the area of the sector is 1/4 the area of the whole circle. But let's write this more mathematically as a proportion, and we can impress ourselves that way. So area of sector over area of circle. That's terrible handwriting, but you can deal with that. And let's be consistent here. Circle. And if you look at the theorem on the left, it says the ratio of the area of a sector of a circle to the area of the whole circle is, area of the whole circle is pi r squared. So we can further write this as area of sector, area of circle, we know is pi r squared, is 90 degrees over 360 degrees. Now what if you were not such a perfect cutter and you were haphazardly cutting slices because you only had a plastic knife, and you in that case you might have an angle which you don't know here, and we'll call that x, which is the same as the measure of arc AB, just reminding you of that. So area of sector in general over pi r squared is equal to the angle that's at the center of the circle over 360 degrees. Note the right hand side is not very different from what you had in the previous section where you found arc length. Arc length is a linear measure, area is a non-linear measure. Okay, armed with this formula, you need to find the area of the sectors by HJK. Okay, when it says areas of the sectors, it really should be area, because I believe the area you need to find here, well actually we do want to find the area. So the second answer which is missing here is 326.73 square units. So I'm just going to highlight this for you. This yellow, that's your minor sector, and the remaining circle is 326.73 square units. I really shouldn't say remaining circle, the other sector. So you have minor sector HJK, and then you have the sector which is HLKJ. Okay, you're given the area of the shaded region here. And what you need to do okay, let me see, do we have some missing information? We sure do. What we need to know in here is the angle measure. The angle measure here is 120 degrees. So now you know the angle, so you can find the radius of the circle first. Okay? Or let's do this way. You don't even need to find the radius of the circle. Here's how I would do it. Area of sector over area of circle is equal to 120 degrees over 360 degrees. I think it's pretty darn simple from there. Yes? Okie dokie. Let's see if we have any other. No, there just seem to be two problems here. As an additional exercise, what you should do is find the radius of the circle. Find the radius of this circle and see if that makes sense to you. Okay? All right, good luck.